are you, students? Are you fine? Are you studying hard in your home by keeping yourself from COVID-19? Okay, well, in our previous lesson summary, we tried to see soil. As you remember, we tried to see the three components of the soil. These three components of the soil are the solid component, the liquid component, and the gaseous component of the soil. Also, we tried to see the acidity and alkalinity of the soil, and we have also seen that the plant nutrients, or what you call plant food, the major plant nutrients, and which are commonly known as macronutrients and micronutrients. Students, in our today's lesson summary, which is Unit 5, the last portion of Grade 8 Chemistry, we tried to see chemical calculations based on formulas. Students, what is chemical formula? What is chemical formula? Grade 7 lesson, you have seen chemical symbols and chemical formula. So, how can you define chemical formula? As you remember, a chemical formula is a shorthand representation of a compound or a molecule. As you remember, formula can be classified into two groups. These two groups of formulas are formulas of compounds and formulas of element. When we say formulas of element, it is composed of only one kind of symbol or one kind of element, whereas when we say chemical formula or formulas of compound, it is composed of the chemical symbols of two or more different elements. And chemical formulas of compounds is composed of two or more elements. So, we try to see how can we determine some chemical calculations based on these formulas. Again, from a given chemical formula, we can have different basic informations. As you see here, from a given chemical formula, we can have qualitative and quantitative data or quantitative and qualitative information. For example, we can understand what the chemical compound is, and types of elements that make up the compound, the proportion of atoms in the given chemical compound, and we can have also the molecular mass or formula mass of a compound. Based on the formula of a compound, we can have such basic informations. Let's see some example. Here we have a chemical formula C6H12O6. From this formula, we can have some basic informations. This formula represents glucose molecule. This is what the compound is. And again, this compound, which is glucose, is composed of the elements carbon, hydrogen, and oxygen. The third one, or C, in what ratio do these elements make glucose? As you see here, in the ratio of 1 to 2 to 1. When you simplify this by 6, 1, by 6, 2, by 6, 1. Taking this information into account, we can be able to determine some chemical calculations. Let's see what these chemical calculations will be. The first thing is atomic mass. Of course, this atomic mass is that you have learned from grade 7. But what is atomic mass? Atomic mass is the exact or true mass of an atom of a given element. Since atoms are very small to be seen or to use in chemical calculations, this atomic mass is not used in our chemical calculations. Rather, we use the average atomic mass of an element or a given element. If you see the atomic mass of oxygen, it is 2.657 times 10 to the power of 20 minus 23 gram. This number is very small, which means 2.657 2.657 over 10 to the power of 23, which is very small to use in chemical calculations. So having this difficulty into consideration, scientists agree to use average atomic mass, or what you call the relative atomic mass. Conventionally, scientists do not assign units atomic mass to atomic mass, molecular mass, formula mass. Simply we use the term AMU to mean atomic mass unit, but they do not have SI unit. But as an SI unit, we use atomic mass unit. Atomic masses for elements which are included in the periodic table are average of the percentage abundance of their isotopes. The average of the percentage abundance of their isotopes. As you know, isotopes, they have different mass but similar protons. So average atomic mass of a given element can be calculated by using this formula, the weighted average of the isotopic masses of naturally occurring isotopes of an element. Here you have an activity. An element chlorine has two isotopes, chlorine 35 and chlorine 37. This chlorine 35 and chlorine 37 has a percentage abundance of 75% and 25% respectively. Then we are going to calculate the average atomic mass of chlorine, the element chlorine. And the other one is naturally occurring copper consists of two isotopes, which are copper 63 and copper 65, with relative percentage abundance of 69.17 and 30.83%. The third equation, the atomic mass of two stable isotopes of boron are boron 10 and boron 11, with percentage abundance of 20% and 80% respectively. So let's see one example and you can try the remaining ones. So average atomic mass of chlorine is one of the isotope of chlorine, its mass is 37 and times its percentage abundance, which is 25%. 25% means 25 over 100 plus, and the other isotope of chlorine 35 its mass and 75%. Then when you multiply 75 by 35 and 37 by 25, you'll have 925 and 2625 over 100 over 100. When you add these two, you can get 3550 over 100. And the average atomic mass of chlorine, or the relative atomic mass of chlorine, is 35.5 AMU, or you can put it 35.5 only. And you can try this one by yourself. The other point that we are going to see is molecular mass and formula mass. Students, what is molecular mass? If you remember the concept molecule, you can try to define molecular mass. Molecular mass is the sum of the average or relative atomic mass of individual atoms in the molecule or a compound that can exist in molecular form. Students, when we say molecule, it can be exist in the form of liquid or gas. For such compounds, we use the term molecular mass. On the other way, what is formula mass? It is the sum of the relative atomic mass of each kind of atoms or ions in the compound, which is ionic compound, composed of positive ions and negative ions of elements. So it is the mass of the compound that contains positive ions of metals, as you remember, and ammonium ions, and negative ions of non-metals. So let's see the step how to determine formula mass and molecular mass. The steps are the same, except we use the term molecule for those gaseous or liquid substances. So in order to calculate formula mass or molecular mass, we have to follow such steps. The first one is you have to identify each kind of element in the molecule or in the formula. The second, you have to decide the number of atoms in each compound. Decide how much atoms are there in each compound, and multiply the number of atoms with their respective atomic mass. So let's see some calculations. Calculate the molecular mass of each of the following molecules. Look what we have listed here. This is decane, as you remember, decane molecule. The decane molecule. This is sucrose. This is glucose. This is carbonic acid. So when you are asked to determine the molecular mass of a compound, you have to check whether they can exist in liquid or gaseous forms. And the second one is calculate the formula mass of the following compounds. Look, calcium phosphate, magnesium hydrogen carbonate, barium nitrate, sodium hydrogen phosphate, aluminum sulfate. Let's see some examples for each. Look, in case of decane, as you remember the steps, what are the elements in decane? These are carbon and hydrogen. How many atoms of carbon are there? 10 atoms of carbon, 22 atoms of hydrogen. You are given also that the relative atomic mass of each element in the bracket. So multiply by 12 for carbon, you are provided with 120 multiplied by 1, you are provided with 22. Then the sum of these two total masses of each element will give you the molecular mass of decay. Molecular mass of decay. And you can try the remaining one by yourself. It is very simple. You have to take care how by using the steps carefully, and you can calculate easily. It is simple calculations. From question number 2, which is formula mass, let's see calcium phosphate. In calcium phosphate, there are 3 atoms of calcium, 2 atoms of phosphorus, and 8 atoms of oxygen. Let's see how it is 8. Look, here we have 3 atoms of calcium, 2 atoms of phosphorus, and 2 times 4, 8 atoms of oxygen. Then that is why we have listed here. So the atomic mass of calcium is 40, 3 times 40, which is 180, 2 times 31, which is the relative atomic mass of phosphorus. It gives us 62. 16 times 8, which is the relative atomic mass of oxygen. It gives us 128. The sum of these total masses of each individual element will give us the formula mass of calcium phosphate. The formula mass of calcium phosphate. You can put it as 310 CDs, or you can use 310 AMU, which means atomic mass unit, as I have explained before. You can do the remaining one. Now let's go to another concept, the mole concept. The mole concept. As you remember from your physics lesson, mole is one of the 7 fundamental physical quantities. And when we say mole in our subject chemistry, it is the amount of substance that contains the same number of particles. Look, that contains the same number of particles. If you take a real example, if you buy or purchase a dozen of exercise book, this dozen contains 12 quantities. Or if you purchase 1 gross of a certain item, it contains 144 individual items. Like this one, we say mole, it contains the same number of particles, which is expressed by Avogadro number. Avogadro number. A person who has determined this number is called Amedeo Avogadro, which is 6.022 times 10 to the power of 23 atoms, or we can say particles in general. So 1 mole of atom, it gives us this much number of atoms, or this Avogadro number of atoms. 1 mole of iron, which gives us Avogadro number of ions. 1 mole of molecule, it consists of this Avogadro number of molecules. This Avogadro number of molecules. 1 mole of formula unit, it contains this much Avogadro number of formula units, because each individual items are different. Each individual items are different. So having the mole concept, we also try to calculate some calculation. The mass of 1 mole of molecule is also equal to the molecular mass in gram. The molecular mass in gram. The mass of 1 mole of a compound is equal to the formula mass of the compound in gram. Therefore, how can we calculate the number of moles? The number of moles in a given question. So number of moles of the substance is equal to given mass of the substance expressed in gram divided by molar mass of the substance in gram per mole. Remember, molar mass means, molar mass here means the mass of 1 mole of a substance. The mass of 1 mole of a substance. For example, what is the molar mass of sodium hydroxide? What is the molar mass of sodium hydroxide? The molar mass of sodium hydroxide is the sum of the mass of sodium, oxygen and hydrogen, which is 23 plus 16 plus 1, which gives us 40 gram per mole. 40 gram per mole for 1 mole of sodium hydroxide. So that is symbolically you can use N is equal to small m over capital M. Small m stands for given mass and capital M stands for molecular mass and N stands for the number of moles. Let's see some example. Calculate the number of moles present in 243 gram of aluminum. 243 gram of aluminum. So, as you have seen in the formula, number of mole of a substance, in our case aluminum, is equal to the given mass of the substance, which is the given mass of aluminum, that is 243 gram, divided by the molar mass of aluminum. As you see here, the mass of 1 mole of a atoms is equal to the atomic mass in gram. When you say molar mass, the mass of 1 mole of a substance. So N is equal to 243 divided by 27 gram per mole. This gram can be cancelled by this gram and you are provided with 9 moles of aluminum. There are 9 moles of aluminum present in 243 gram of aluminum. So we can calculate in such a way. The number of moles can be determined or calculated in 2 ways. The first one is that we have seen before, and the other one is we are given in terms of Avogadro number. So number of moles can be expressed or calculated as given number of particles, which is expressed in Avogadro number, divided by 6.022 times 10 to the power of 23 particles per mole. The number of particles in 1 mole of a given substance. Look the example here. Calculate the number of moles present in 12.044 times 10 to the power of 23 molecules of ammonia. In this example, the number of mole, which is N, is equal to given number of particles. In our case, we are given molecules. Particles is replaced by molecules. 12.044 times 10 to the power of 23 molecules divided by Avogadro number of molecules per mole. So you can cancel by this molecule by molecule, this by this one, and when you divide this number by 12.044 divided by 6.022, it gives you 2 moles of ammonia molecule. Okay. This is an activity for you to do in your home individually. So here you are given, calculate the number of moles present in 250 gram of calcium carbonate, 200 gram of sodium hydroxide, 24.08 8 times 10 to the power of 23 atoms of carbon, and D 18.066 times 10 to the power of 23 molecules of hydrogen, and the last one E 20 gram of calcium atom. So students, you can try this one, very simple exercise. You can try by yourself individually. And the last point is percentage composition. Percentage composition. As you remember, percentage is familiar term for you, but in our subject chemistry, for what purpose do we use percentage? Do we use percentage? So percentage composition of a compound is the number of parts by mass. The number of parts by mass of each individual element in 100 parts by mass of a compound. By mass of a compound. So in order to determine percentage composition by mass of each element in a given chemical compound, we use this formula. Percentage composition of each element in a given chemical compound can be calculated as the mass of the element in the compound. This is to mean compound, CPD. In short, it is to mean compound. And divide by the formula mass or molar mass of the compound, then we can multiply with 100. When we determine percentage composition, we have to follow some steps to make it clear for your understanding. You have to follow certain steps. The first point is you have to identify the number of atoms or the number of elements in each compound. So what type of elements are there in the compound is the first thing. And the next step is calculate or determine the total mass of each element in the compound. You have to calculate the total mass of each element in the compound by multiplying the number of atoms by its relative molar mass. Third one, you have to calculate the molar mass of the compound. The molar mass of the compound. Molar mass of the compound. Then 4, calculate the percentage composition of each element in the compound by dividing the total mass of each element by the molar mass of the compound. The molar mass of the compound. Look this example. In elements in sodium carbonate, for example, it is composed of sodium carbonate, as you remember this one. Sodium carbonate. There are 2 atoms of sodium, 1 atom of carbon, and 3 atoms of oxygen. So the elements are sodium, carbon, oxygen. The mass of each element, 2 times 23, 46. 1 times 12, it gives 12, and 3 times 16, it gives 48. Then you have to sum up this one, and you are provided with the molar mass of the compound is 106 gram. And percentage by mass of sodium is equal to 46, the total mass of sodium, divided by 106, the molar mass of the compound, sodium carbonate, times 100%, it gives you 43.4%. Percentage by mass of carbon, it gives us 11.3% by dividing 12 by 106. Percentage by mass of oxygen is calculated as 48 divided by 106 times 100%, it gives us 45.3%. Students, what you have taken here is that the sum of the percentage composition by mass of each element should give 100%. So when you sum up 43.4, 11.3, 45.3, it gives you 100%. 100%. How to determine formulas? There are 2 types of formulas, molecular formula and empirical formula. When you say molecular formula, the actual formula that gives complete information about the identity of the substance, what the compound is. When you say empirical formula, it is the simplest formula. It simply shows the ratio of atoms in a given chemical compound, but it does not tell us what the chemical compound exactly is. But different compounds may have the same empirical formula, but different compounds can have different molecular formula. They may have the same empirical formula, but they do not have the same molecular formula. In order to calculate each empirical formula or molecular formula, we have to follow these steps. We have to write the symbols of the elements, and we have seen also percentage. We have seen in the previous exercise, write the percentage composition by mass of each element under their symbol. Then we divide their percentage by the relative atomic mass of each element, and we divide the number of moles of all elements by smallest one, obtained in this step 3. And if we have a fraction of moles, we have to convert or change into an appropriate integer by multiplying it a necessary number. And this last one, write the symbols of elements side by side, and we try to write the empirical formula of a compound. If you take this one, a compound is composed of 85.6%, 64% of carbon, and 14.36% of hydrogen biomass. Determine the empirical formula of the compound. Here in this case, what are the elements in that compound? That unknown compound, carbon and hydrogen. What is their percentage? Carbon is 85.64%, hydrogen is 14.36%. We divide by its relative atomic mass and its relative atomic mass. Then we are provided with 7.14, and here we are provided with 14.36. So the smallest of the two numbers is 7.14. So we have to divide both by 7.14. 7.14 we are provided with 1 and 2. We use CH2 as empirical formula of the compound. Students, this is about Unit 5, which is calculations based on chemical formulas. So you have to do more exercise in your textbook, and you have to prepare yourself for regional exam. Thank you for today's presentation.